Hi everyone, and welcome to the second part of the instructional video dealing with translation. This instructional video is about going backwards. Let's look at this example here. What is given to us is the post-translation, meaning after we translated, which is given as for every x value we go right 3, and for every y value we go down 5, wherever it was. And what ended up is A prime, B prime, and C prime. And the direction is find the initial position, meaning before we translated and brought here right 3 and down 5, they want us to find the original position where it used to be. So we're going to do this two ways. First, we're going to do this physically counting, just like in the previous instructional video. So let's look. Let's look at the A prime. We ended up over here. To get here, we had to move on the x-axis horizontally 3 units. 1, 2, 3. So we're going to go backwards. It's like tracing back to where you were, walking back. So it says plus 3. So from 4, we're going to go 1, 2, 3 to the left. And then we had to come down 5 units, so instead we're going to go up 5 units. 1, 2, 3, 4, 5. And that was the A. And now we have to determine what the original coordinate was. So on the x-axis, from the origin is 1 unit to the right there. So x is 1. And y is from the origin on the vertical axis, 1, 2, 3, 4, 5, 6. So the original coordinate was 1 and 6. We had to go right 3, 1, 2, 3, and down 5. We're going to do the same thing with the B prime to find the B. From here, we're going to go, it says to go right 3, so we're going to go left 3. 1, 2, 3. And instead of down 5, we're going to go up 5. 1, 2, 3, 4, 5. So that's where the B used to be. And the x and y coordinate for that is 1, 2, 3, 4, negative. And 1, 2, 3, positive on the y-axis. And finally for C prime, to find the C, we're going to do the same thing. Instead of going right, we're going to go left 3. 1, 2, 3. And instead of down 5, we're going to go up 5. 1, 2, 3, 4, 5. And that was the original C position. And the coordinate for that, as you can see from the origin, on the x, 1, 2. And the y is 1, 2. And then, if you connect all those 3 vertices together, again, the rigid transformation concept holds true because we have a same shape and same size. That original form has not changed. It just shifted to the right 3, down 5, and we found the original. Now, for second part, we're going to do the same thing, but we're going to do it algebraically, and we don't even need the graph. Let me explain. What you do to find the A, which was, what you do is take the A prime, which was x and y is 4 and 1. And now what you're going to do is take that x plus 3 and make it into an equation. Whatever we did, added 3, remember, we ended up with a 4 for the x value. So this becomes what we call a one-step equation. To find out what the x is, we do the inverse of plus 3 to isolate or solve for x. So inverse or backwards of plus 3 is minus 3, but in equation, as the word equation implies, whatever you do to one side of the equation, you must do it to the other and line it up. So on the left side, 3 and minus 3, that's called an additive inverse. The sum is a 0, so we just cross it out. And what remains is an x. And as you can see, 4 minus 3 is 1. So the x value is 1. There it is. And we did the same with the y. Y minus 5. And what we resulted was a 1 over here. to solve for y, we do the opposite or the inverse of minus 5, which is plus 5. Again, wherever you do to one side, you do it to the other as well. So negative 5 and plus 5, the sum is 0. We just cross it out. And 1 plus 5 is 6. So the actual x and y value for the a is 1 and 6. Ta-da! So when we do that quickly, now let's do, Now given the minimum space, I'm going to do it right over here. Here's what we do. We go x plus 3 equals, this time, b prime, which is minus 1. And we go y minus 5 is equal to negative 2. We go minus 3, because that's the inverse of plus 3. Can you guys see that? Here, hold on. There we go. There. Plus 3 minus 3, they gone. And now you have to be very careful. Minus 1 and minus 3, when you combine them together on a number line, you get minus 4. And we go plus 5 on this one. You see, the operation is the same for every one of these. You just get different values. So y is equal to negative 2 and plus 5 is positive 3. So the x and value for b, in this case, is going to be negative 4 and 3. And there it is. And the last one, we'll do it over here. We're going to write the same. Where'd it go? Let me zoom out instead, folks. Oh, wrong way. There we go. Instead, this time, we're going to take that same expression, x plus 3, but we're going to put the c value, x and y minus 5 is equal to negative 3. And this is for c. So we got minus 3, x is equal to 2, plus 5, y is equal to positive 2. So C, the original location, should have been 2 and 2. Ta-da! Enjoy.